Hey guys, so I'm going to show you how you are going to graph an absolute value function that looks something like this. So as we saw before in the video I posted earlier for you guys, if you have the absolute value of x as your function, so if f of x is equal to the absolute value of x, you're turning that into a piecewise function and then you're graphing it from there. Since you're working with two different parts of the function, you're working with the positive part and the negative part. So you're working with your positive x values and your negative x values. So when we're looking at something like this and you see this problem and you don't know how to graph it yet, that's totally okay. I'm going to show you guys like some really simple steps because like this could be considered a more complex function. It's not like super complex. As you go through calculus, you're going to see more complex problems, like much more complex problems than this. But the idea is seeing something that when you look at it, it might not feel familiar, you might not totally understand it, or it might not be super intuitive to you, and trying to break it down so that you can take really simple steps that are really easy, like anybody can do these steps, and it'll help you solve these more complex problems, especially when you might still be unfamiliar with working with functions like this, because I don't know how much we do this in college algebra or pre-calculus. But it's really helpful in calculus just to be able to break problems down, because a lot of calculus you are working with forms of complex functions, and so it's really helpful like on a test or a quiz or something like that, or during your homework, just to break it down into small steps, so that even if you don't know how to totally get to the answer, you at least know partially how to get to the answer, and that can help you figure it out, or at least you get partial credit if it's a written exam or a written quiz. Instead of just looking at this and having absolutely no idea what to do, it'll really help being able to at least do a couple steps of it. So the first thing that we want to do is, so this form currently is obviously not written as a piecewise function. So we want to write this as a piecewise function. That's going to be our step number one for a problem when we're given this form. I know before I told you that when we're working with piecewise functions, the first thing you want to do is do a number line, but we don't have that piecewise function yet. So right now we only have it written as this function. So we want to turn this into a piecewise function, and then we can go from there in terms of like graphing and plotting and figuring out the number line and all of that stuff. So when we are turning a regular function, so I'm going to just use f of x is equal to the absolute value of x as my example. What you're doing is you're taking that the absolute value of x is equal to the piecewise function of the positive version of x when x is greater than or equal to 0, and then negative x when x is less than 0, right? Because you're just talking about, again, what I showed you before. We're looking at the x-axis. You're not looking at your y-axis, because for your absolute value, your f of x is going to be positive because you're looking at absolute value numbers when you're talking about the absolute value of x. But the values that you plug into this, you are able to plug in negative values from your x-axis. So we're talking about the domain here. We're not talking about the range. And so when we're talking about the domain here, we know that when x is greater than or equal to 0, it's positive. When x is less than 0, it's negative. And so what we did for this absolute value is, or for this function or this piecewise function, you take what is on the inside of your absolute value signs and you use that for your piecewise function. So when we're working with these absolute value problems, what you're doing is you're using what is on the inside of your absolute value signs. You're not using anything that's on the outside. So if this was like x plus 4, this would still look like this when you're turning it into the piecewise function. You're not going to have that plus 4 written like that because the 4 is on the outside of your absolute value signs. But if you're looking at x plus 4, then this would be different. Then you would use that x plus 4 on the inside. So when we're working with these piecewise functions like this, what you're doing is you're just taking anything on the absolute value sign, inside of the absolute value sign, and then you're plugging it into this format. So if we were going to just write it as like an empty base, you would have your absolute value signs, and then whatever's on the inside, so the inside, and then that's going to be equal to the absolute value of the positive version of the inside, and then you're going to set the positive version of the inside to be greater than or equal to 0, and then the negative inside to be less than 0. And so the reason that you're doing this is because there are going to be times where like your signs are going to flip around and things are going to look a little bit differently, but when we're working with our piecewise function, we're only working with the absolute value for setting up the piecewise function. When we're working with the function as a whole, we're going to use all of the information from the function, but right now, setting up this piecewise function, just these initial first steps, we're only working with that absolute value part. So what is the inside of our absolute value function? So we are given that we have the absolute value of t minus 2 is equal to, and then some information. So this is not going to be our final piecewise function format for this function. This is just the initial one. So we're going to have to like plot it on like number lines and see like what things are going to look like graphically, and then we can see if things change for our piecewise function. But this is just the first step. So like this is our, like I'm going to say maybe it's like our draft piecewise because it's going to change. But this is just to kind of get that initial information on here. So, oops, I messed that up a little bit. So we have t minus 2 here. T minus 2 is our inside. So we have positive t minus 2, and then we're going to set a negative on the outside and negative t minus 2. And then comma, comma. So now we're going to have t minus 2 is greater than or equal to 0, and then t minus 2 is less than 0. So looking at this, we have this t minus 2 is greater than or equal to 0, and t minus 2 is less than 0. We want to find what t is. Like we're kind of like, it's basically like using x. We're really trying to find when x is greater than or equal to 0 or t is greater than or equal to 0. Not necessarily it's t minus 2. So in order to solve, we just want to solve this part of the equation. We're going to add 2 to both sides, and then you're going to have t greater than or equal to 2, and then t is less than 2. So this is what we're going to be looking at just for this initial step of the problem. We have t minus 2 when t is greater than or equal to 2, and then negative parentheses t minus 2 when t is less than 2. Make sure you carry your parentheses or work with your parentheses here because this problem is very different than just having negative t minus 2. This is parentheses t minus 2. Like there's a very big difference between having this negative on the outside with the parentheses. So now that we have this written as a piecewise function, the next thing we can do, we're going to make our number line. And so remember, when you're making a number line for your piecewise function, what you're doing is you're taking the points given by your piecewise function and you're setting those on your number line. So whatever you're working with on your piecewise function in terms of less than or greater than, whatever values you're given, you're going to make a number line, and then those are going to be the values that you set on that number line. So you're going to set number, or maybe say plot number given by piecewise function. And that number that we're given is 2. So what do we know about this? We know that when we are a t value that is less than 2, so going this way, we're going to be working with this negative t minus 2. And then when we're working with a number that is greater than or equal to 2, we're going to be working with the positive form of t minus 2. And so now we can kind of write this out into different functions. So I know that my original function is f of t is equal to the absolute value of t minus 2 over t minus 2. And so we're going to have the positive form, which is going to be t minus 2 over t minus 2. And then we're going to have the negative form, which is going to be negative t minus 2 over t minus 2. So when you look at it written like this looks like it's just going to end up equaling 1. And this looks like it's just going to end up equaling negative 1, right? Because we don't really need to plug any values in here to see that t minus 2 over t minus 2, when you divide something by itself, you get 1. And then this is the same exact thing, but you have a negative out in front. So it looks like that's what our values are going to be equal to. But let's actually plug some stuff in and solve that. So going back to our number line, let's pick a couple numbers. We can say that we're working with 0. Let's pick negative 1. Let's pick like negative 7. And then let's pick 3, 4, and 7. I'm just picking some random numbers just to kind of show like just to test if it works for a variety of numbers. And then I might pick a number that's like really, really high just to make sure it goes when it expands all the way out. So let's say 82, negative 82. And then when we're going all the way out here, let's say we have positive 95. So we're going to have f of t, and let's first work with the positive format. So we have f of t, but I'm going to do this in the table. So I have t, and then f of t. So what are we plugging in? We're going to look at negative. So we're going to do, I'll start with the positive side. So we're going to do 2, 3, 4, 7, and 95. So plugging this in to this format of the problem. So for 2, we have 2 minus 2 over 2 minus 2, which is equal to 0 over 0. So this is not 1 over 1, right? Like this is not equal to 1 because you cannot divide by 0. It doesn't matter if you're dividing 0 by itself. That does not equal 1. You can't divide by 0, so it actually looks like going back, and this is why it's a draft piecewise, because it's not what our official form of the problem. And since it's a draft piecewise, we're looking at this. We said that t, when t is greater than or equal to 2, but to me it kind of looks like t can't be equal to 2 because you have a 0 in the denominator, and it doesn't matter what's in the numerator. You can't have 0 in the denominator because that is undefined. So this is actually going to be undefined. And so what I'm going to do is, going on to the next page, I'm going to write more of my official version of my piecewise, where I have my f of t is equal to, so using my piecewise, I'm going to write something in here and something in here. I don't have that quite yet, but instead of having when t is greater than or equal to 2, I'm just going to say when t is greater than 2. And then I know I'm going to have when t is less than 2, but maybe this will change when we look at the problem, but it also might not. So let's see what we're looking at when we're looking at this problem. So when we have 2 on the negative value, it's undefined. So that's why we take it away. It's not going to be equal to 2. It's just going to be greater than 2. So when we go back to this, we would actually erase that, and we're actually going to make this an open circle. So this is why like doing this method also helps, because a couple steps ago, like I did see that this is equal to 1 and this is equal to negative 1. I can kind of tell that by just looking at it. But if I didn't plug values in and test it out, then like I wouldn't see that I actually have something undefined here, and that's really important for the problem. So now let's plug in a couple more things. So let's say we got 3. So we have 3 minus 2 over 3 minus 2 is equal to 1 over 1, which is equal to 1. And then if we do 4 minus 2 over 4 minus 2, 2 over 2, which is equal to 1. And then I'm going to guess that this is going to be 1. If I have 95 minus 2 over 95 minus 2, that's equal to 93 over 93, which is also equal to 1. So to me, it's kind of looking like when I have my positive t values, so my t values that are greater than 2, over here, my value is just 1. And while I'm working through this, I can actually make another number line to kind of graph this out a little bit, because we could do it going back here on top of this number line, but that's a little bit messy. So again, we have 2, and so I'm going to have an open circle here where our line's going like that, and when our t is greater than 2, our function value, our f of t, is just going to be equal to 1. So our output is just equal to 1. And now going back, let's test out some negative values. So when we're testing out our negative values, I think we said, so we're going to do 0, -1, -2, -7, and -82. I'm just picking, again, some random numbers. So plugging this in, I have negative, and then I have 0 minus 2 over 0 minus 2. So if I have 0 minus 2, I just have -2, and then that becomes +2. So I have 2 over -2, and this is just equal to -1. If I plug in -1 minus 2 over -1 minus 2, this is equal to 3 over -3, which is equal to -1. If I plug in 7, I get -7 minus 2 over -7 minus 2. So this is -9, and the -9 cancels out with that negative. So I have 9 over -9, which is equal to -1. So as you can see, I'm just getting -1, and we'll double check this again for this -82 minus 2, -82 minus 2. So you get -84 over -84, but we have that negative on the outside. So again, this is just -1. So going back here, so we don't have, if we test out 2 on this, let's see what happens, because maybe this will be equal to 2, but let's just double check and test that out. Because going over here really quickly, I can see that I'm going to have -1 when t is less than 2, but let's see if this would be equal to that 2. So if I plug in 2 minus 2, make that negative, and then 2 minus 2, again, I'm going to be dividing by a 0, and we do not divide by 0, so this is going to be undefined. I don't even have to work it out. I can just look at that and see that's going to be undefined. And so since this is undefined, this is going to stay written exactly like that. And then again, in the numerator, you're just going to have no greater than or equal to. It's just going to be greater than. And so now coming back to our graph, when it is not equal to 2 but less than 2, our f of t value is equal to -1. So now finally getting to the point where we can graph this. So looking at the graph for this, we can use our number line here. So we're going to look at the value 2 on our x-axis, and then we're going to look at 1 on our y-axis and -1 on our y-axis. So when we're going to draw an open circle here, when we are not equal to 2 but we are greater than 2, our f of t is just going to be equal to 1. And then when we are not equal to 2 but we are less than 2, our f of t is just going to be equal to -1. And so your graph should look something like this for this piecewise function, and that's how you would solve this problem.